Hello there. Today, you're going to get 2 notebooks that cover how to build agentic system, AI agents, one using PydanticAI and the other using Small Agent. And everything is available on the Gen AI Showcase. I'll tell you what we're going to be building today. So we're going to be building a hybrid RAG system with PydanticAI and MongoDB. It's going to be an AI agent for searching tech news and retrieving real-time news from the internet. And as usual, all the code that I'll be presenting is available right over here on the Gen AI Showcase repository. So the Gen AI Showcase repository contains a bunch of code for all different use cases, RAG, agentic, evaluations as well. And we have some new entries just literally this week covering all the new developments that have been happening. So we have small agents over here. So if you go into the agentic use case, you go to the agentic showcase GitHub repo, you're going to see 2, not 1, but 2 notebooks on using small agents from Hugging Face. But today we're going to be looking at PydanticAI. So most folks within the Python ecosystem of Python developers are familiar with Pydantic, but they released an agentic framework that is in beta. So there's still going to be a lot of changes, but it's in beta. And it's, I have to say, in my opinion, one of the simplest and quickest way to get an AI agent system running with about 5 lines of code. We're going to see that today. And most of the patterns we see in building these agentic systems and using different frameworks are relatively the same. You have a model, you wrap the model around an agentic wrapper, then you connect your agent to a bunch of tools, which can be Python functions or microservice. Those are the patterns. And obviously there's more work going behind, but some frameworks are more opinionated than others. But with PydanticAI, it's very minimal and it's aimed at actually creating agents that are backed by types. So the Pydantic types, essentially. So agents within Pydantics can be types as well. We'll look at examples of this, and we'll look at examples of how to build tools and passing dependencies from your environment into the agent. So there's going to be a lot of things we're going to cover. And as usual, we're going to be using MongoDB. We're going to build a RAG pipeline. We'll go through all the good stuff just to make sure that we haven't forgotten how to build a RAG pipeline over the holidays. So these are the steps we're going to be taking, 9 steps. And I like to do something different where I show you where we're going, then we can work backwards from there. So we're going to be creating a very simple agent that has access to tools. Let me show you what the output looks like of the end process. So in the end process, we're going to be asking the query, get me some news on electric cars if possible. That's the end process. And this agentic system we're going to build is going to be able to go to the internet and also look into an existing database and combine the results to give us a response based on the query of get me some news on electric car if possible. So we can see that the AI agent responded with 5 of the latest news and some of the latest news on electric cars. I have to remember what it was. But you can also see it got some information from the database as well, because you can see that this is 2023. But you can see here the rest of this is actually more latest news, so 2025. So we have this data from what is an existing knowledge base. Then we have data from what is the internet. So this is what we call hybrid RAG. And we're using, and it's called hybrid RAG because we have 2 different systems giving us information that we're retrieving information from. And we're using Tavily to build out this hybrid RAG system alongside with MongoDB. But we can also see the results of the execution as well. We're going to look into this. It's not really friendly to look at the moment, but we're going to look into some of the execution. But this is what we're working towards, an agentic system that when we run it, can search to an existing database and also search on the internet and combine the results to give us a very clear answer to our query. As usual, you can put where you're tuning in from on the comment section. And also you can ask questions as we go along. Any questions really related to AI, related to agentic systems, related to RAG and vector databases. So ask any questions, and you can also let me know what some of your biggest pain points are when you're building this agentic system and what you would like to see in the Gen AI showcase. On that note, I'm going to go through all the steps that took us to get here. So we'll start from step one, and it's pretty trivial now. It's basically just installing all the libraries and tools we need to create our AI agent. So PydanticAI, PyMongo, datasets, which is a Hugging Face library for the dataset that are on Hugging Face, Pandas, and Tavily Python. This is going to be the library we use to access and connect our LLM to the internet. I've kept in some information on what we're trying to solve in terms of the core problem and the solution itself, but also some real world application of this basic foundation of this basic agent system that we're building and how you can apply it. So you can use what we have here for enterprise intelligence, financial analysis, and research monitoring. On that note, after you've installed your libraries, you need to set your environment variables. So we're going to be using the OpenAI model. We're going to be using GPT-4 Omni, but the PydanticAI framework is model agnostic. So it has some built-in models that you can load, but you can also actually create your own custom classes to connect to any other model. So it's model agnostic essentially. I'm using OpenAI because it's one of the most popular models that folks are using today. So, and if you're going to use OpenAI, you're going to need an OpenAI key. Place the OpenAI key in your environment. So today, in step 2, already, we're just going to create a very simple agent. This is the most basic agent you can create with PydanticAI and OpenAI. So on that note, this is a very simple agent. Just to refresh, an agent is a computational entity essentially that has an LLM. The LLM enables some form of planning, reasoning, the composition of an objective into task, but it also has the ability to perceive its environment through text inputs, audio, or images. But an AI agent is also backed by memory. So this could be short-term or long-term memory. We're going to be seeing 2 examples of memory. So we're going to see short-term, and we're going to be looking at working memory. But for long-term, we're going to be looking at the knowledge-based aspect of long-term memory. And MongoDB is going to be both our operational database and our database. So here we have tools as well. So we're going to be creating tools for our agent. And these are the basic bare bones of our components. These are the basic components of an AI agent. So to create a very simple agent, already in step 2, what we're going to do is very simply import the OpenAI model. That's what we're going to use. And then the agent module from PydanticAI. And what we're going to do is assign the OpenAI model, specifying GPT-4.0 to the variable model, and then wrap the model in an agentic class, essentially, and give it the system prompt that says, when provided with a sentence, simulate shouting. So simulate shouting by basically putting the entry in uppercase. So that'll be shouting in caps lock or uppercase. I've kept some explanation as to what's going up here, but this is all it takes to run or to create an AI agent with PydanticAI. Very simple. This is about 5 lines of code, and you can maybe even shorten if you move line 8 into line 11. So this is very, very simple and effective. And when you run this, when you want to run an agentic or an AI agent with Pydantic, you have 3 ways of running it. I've explained all the 3 here in this notebook. So this notebook has a lot of explanation because this is the first introductory explanation into PydanticAI, and it is in beta, so a lot of things might change. But at the moment, this is what the functionality on PydanticAI is. So run sync allows you to execute your agent in essentially what is a loop until the agent calls out of the loop and then provides the response. So the entry or the prompt I gave this agent is this sentence started off initially quieter, and then it converted it into what is a simulation of someone shouting. Remember, you can ask any questions on the chat and I will get to them when we're taking a slight break. But so there are 3 ways you can actually execute or run an agent. So I've explained them over here, and that's it. Very simple. We have an AI agent with PydanticAI. In step 3, what we're going to be going through now is to build out this knowledge base for our AI agent and actually use vector search to retrieve some information from our database to conduct semantic search. We're going to be retrieving some information via semantic search. So we'll go into step 3, and this is a typical RAG pipeline process. Let me see if I can zoom in here. Is that too big? It's never too big. So this is a typical RAG pipeline process. And here we can see we're going to start with data loading. We're going to be loading the tech news embeddings. Now, this data set is available on Hugging Face. And I've kept the link here so you can see the data set and its composition. And we're going to be using 10,000 data points. This data set contains 1.5 million data points. We're only going to be using 10,000 data points for this particular use case. And you can expand it based on your compute environment to use as much of this as much data points as you want. But we're going to be loading this data set. We're going to load 10,000 data points, and we're going to convert it into a data frame and assign it to this variable dataset underscore df. So the next thing we're going to do is just view the data set. So this data set contains different data points that point to a news article or a news on a tech company, essentially. So in the first data point, we can see the name of the company is O1 Synergy, and this was the link to the news, and this is the date it was published, and this is the URL, the title, and then you have things like the description, and then you have the embedding. This embedding was generated using text embedding small 3 or the one from OpenAI using the dimension size 256. So it's very small, and we're embedding the description, the title, and the company name. So those are the data attributes that this embedding was generated from. So as we move along, we have 10,000 of these embeddings. And one thing we're going to do is some cleaning of data here. We're just going to remove the underscore ID attribute from this data set. And then we just check again to make sure we're good and it's all removed. And yes, it is. And now we can move on to the next step. But before we move on to any of the other aspect of a RAG pipeline, we're going to be using the Pydantic library itself to actually create some models for the data set that we have for each data point we have. So we want the data point within our data set to conform to a certain data structure or a certain model. And this allows us to, one, identify any sort of outlier data points that might be missing some of the attributes that we're looking for, and also enables us to validate the content of each of the attributes as well. So we want just the company name, the company URL, publish that title, description URL, and embedding from each data point within a data set. And this is the model that we've created. It's called a tech news data. And you can see we don't need the image. So I've removed the image. I don't need the image to get ingested into my database. I don't need it. I don't need my agent to be aware of the image. But now we're going to actually conform each of the data point to this model that we have created. And it's just a straight one line. And now that we've done that, we're going to leave it there. We're going to move into generating an embedding. So we need to do this, even though we have embeddings for our data set, we need to do this for the embeddings that we're going to be generating from the user query to conduct vector search on between the user query embedding and the embeddings within our knowledge base collection. So this is why we have this function, and it's very simple. We're going to be calling the text embedding free small model, passing it an array of text, and it's going to output a list of embeddings for us, each one corresponding to each text that was provided in the list. So this is very simple. This function is going to be used later on. Again, ask any questions if you have them, and I will get to them. So if we move on to step 5, we've done this a lot of time, but I'll go over it. This is just connecting to your MongoDB database. You can create a free MongoDB Atlas account. You create a free tier account, and you can actually go through this example along or in your own time. But once you've created your MongoDB database, you created your collection, I'll show you what that looks like over here. And once we have some data ingested. But once you've created it, you can also access your connection string to actually connect to your cluster. Then once you've actually placed in your connection string in the Mongo URI within your environment, you can then actually move on to connect to it. So this function does one thing, and that is connects to your database. It gives you an object that represents a connection to your cluster, which you can use to extract the databases and collection within a cluster itself. So what we're going to do now is we're going to create a database called Tech News Agent. Then we're going to create a collection called Knowledge Base. It's very straightforward. So from there, we're going to actually either we create or we get the database name. So this function, this part of the code does the creation if we don't have it already. But then if you do have it, it would just retrieve the collection, the database and the collection as well. So here we can see this was the first time I was running it. And here we can see that the knowledge base was created successfully. So far, we've loaded some data, 10,000 data points. They have embeddings already, and thanks to Hugging Face and the data set on the MongoDB organization on the Hugging Face. And then we've used Pydantic to create a model that each data point within a data set can conform to. Now we've also made a connection to our database that's been created and connected to our collection, or either connected or created a collection. The next step for us to be able to conduct vector search is to create the vector search function. But before we do that, we're actually going to ingest the data into the database. So the data points of all the tech news, we're going to ingest it into our database. So our collection is going to be the knowledge base. We're going to clear it because sometimes it might run this several times. So we're going to clear it to make sure it's clean. And when I ran this, it's 0 because it was the first time. There was nothing to, delete. But I explained very quickly why MongoDB for AI workloads. Very simple. MongoDB has an affinity for JSON-like structured data, which means that you avoid some deserialization and serialization you might get with other databases. So this really makes the process of implementing RAG pipelines a lot quicker, less code, as we can see. An ingestion process can be just one line. So here we have the documents. We create a list of all of the data points, and then we just insert it using a batch insertion into MongoDB. And that's it. Right now, the data ingestion would have been completed. Before we go into the vector search index creation and the vector search function, I want to show you what the data will look like when it's been ingested. So here we're in MongoDB Atlas, and here you can see all the buttons. You can create your database here, and just click here to create your database, and you create your collection name. But I've done all of that, and I have my database. The database name is Tech News Agent, and the knowledge base is right over here. So you can see we have the 10,000 documents, and you can see we have the embeddings over here as well. We have the URL, the description, and obviously the image. We didn't want the image, so the image is not included in the documents that were ingested. Again, ask any questions if you have any questions, and I'll get to them. So if we go back to the code, we're still going through the process of a typical pipeline. So if you've done this several times or you've seen this live show, this might be familiar already. Next thing we're going to do is create our vector search index. And this will allow us to efficiently retrieve the data points that we require during a vector search operation. I mentioned efficiently do the retrieval. So vector search index will allow us to do this. We're just going to set this up. We're going to be doing it programmatically. You can also do it using the GUI over a MongoDB Atlas. So you just click on search index, and you can create a search index over here, and you can create a vector search index. So I've already created one, and that's a duplicate name where you can change it. You can create a new name, but we'll be doing it programmatically here. And you just run this cell, and this will create the function to create the vector search index. We're going to be defining what the actual vector search definition, the actual vector index definition looks like. So here, the type of index we're creating is a vector. You have to specify the path of where your embedding is located within the documents that we ingested, and is located in the path or the attribute or field embedding. Also, this has to match the vector embeddings in the dataset. Then the dimension size is 256. This matches the dimension size in the actual dataset. All of this is just to create the knowledge base. So moving a little bit quicker, we create the vector search definition, we create our vector search index, and now we've moved on. Now we can define this custom vector search operation, a function that we're taking a user query, convert it into a numerical representation or vector embedding, then conduct vector search against the user query and the embeddings we have in our database. Then we have some stages. The way you actually transform data in MongoDB is using the aggregation pipeline. And within the aggregation pipeline, you have several stages. Here we have the vector search stage and we have a project stage. The vector search stage is very descriptive. It just runs a vector search operator with some parameters, and then it conducts vector search. Then with the project stage, what we're doing is we're actually specifying and including and excluding a specific field. So we're only excluding the ID and we're including the rest of the field we want. In addition, with the vector, with the relevance or the similarity score of the vector that we actually retrieved. So here you can see that we create a pipeline, and then we pass the first stage, which is the vector search stage. Then we project out the documents or the attributes we don't need. I'm also extracting out the amount of time it takes to complete the vector search operation as well. So notably here we can now use that custom vector search function, pass in the statement, get me some news and electric cars if possible, tell it the collection we wanted to actually extract some data from. And here we can see we've extracted some documents which are semantically similar to this query. So we extracted 5 documents there. I'm not sure if Aerojet obviously is not an electric car company, but here we can just see some documents that have been retrieved, and we have the score as well. So this is I guess relatively low if you're using the OpenAI. Anything around the 0.7 or less is pretty much a low relevance. But we've retrieved some documents nonetheless. Now we can move on to the fun part, which is creating the PydanticAI agent, which we did already. It was very simple, about 5 lines. But now we are going to create the Pydantic agent with tools. Before we had the agent, we had the LLM within the agent, and it just could answer queries. Now we're going to give it the ability to access the internet, the ability to access a knowledge base, and do other things using tools. So I'm going to take a very quick break to see if there are any questions. Just going to go through and see if there are any questions, but you can also remember you can ask questions in the chat, and GitHub repository that I'm sharing, the code that I'm sharing has been shared on the link on the comment. The link for the code I'm sharing has been shared on the comments. I'm mixing my words together. Okay, so let's go. Yeah, so I don't see any questions. I think the only question there has been answered. How is type safety ensured by PydanticAI? So type safety is ensured by PydanticAI by I'll actually go through it, and documentation is here as well. So there is the PydanticAI documentation covers this, but each agent, you can actually specify the input type. Just to answer that specific question, you can specify the input type that you expect from any data passed into the agent. And you can also specify the dependencies and the structural dependencies as well. That way, each agent is actually your IDE. If you have ints on your IDE enabled, you can actually see if your agent doesn't conform to the type that you've specified. I don't think I'm using that here, but I don't think I'm actually specifying any types here, but we'll see it. But the documentation has that covered. And maybe if I have some time, I can show that to you. But another question just got here. I need to know, do you run the database on a schema? I'm trying to understand what the question is. Sam, if you can answer that question a little bit, if you could rephrase the question for me to answer it. But do we run the database on a schema? I'll give an attempt, right? So the schema with MongoDB, you don't have to specify a schema, but we have tools that allows you to actually validate your schema, and you can actually specify schemas with any of you can specify the schema that you want your documents to conform to during ingestion again with MongoDB. I'm hoping that answers the question, but you can always rephrase the question for me to get to. And the last question is, I have 5 million records in my collection. How intensive is the size and compute for the nearest neighbor vector setup? Well, I don't know specifically because I don't have access to your cluster. But one thing I can tell you is with 5 million records, and I'm guessing you have 5 million embeddings or maybe 5 million plus embeddings, you can have a high latency in terms of searching through that much vector embeddings. Also, it could affect the storage or the memory footprint of your collection as well. So one thing MongoDB does have is automatic quantization, and we have an example of how to do that in the Gen AI showcase. So I will just quickly go over to the Gen AI showcase and show you where you can, when you're actually having a large scale vector embeddings, when you go past the 1 million plus, then you can actually start looking at using automatic quantization. So if you go into the Gen AI showcase, go to notebook, and also leave a star and a fork on the Gen AI showcase, then you can go into, if I remember, techniques, and we have different quantization notebooks. And I think the latest one is here. Here we show you how to actually turn on automatic quantization, right? Reducing the latency. And we've used nomic embeddings, and we show you how to turn it on very quickly just to show you how you can do this. It's very simple. By specifying quantization, the quantization field on the vector index, you can specify the precision data type you actually want your full fidelity vectors to take on. So whenever you generate some vector embeddings from embedding models, they're taking on float 32. But by specifying quantization, the quantization type, you can actually reduce the precision data type to scalar, which is int 8, or binary essentially, which will allow your vector embeddings to take on the elements within your vector embeddings to take on the values 1 and 0. So you can go through this notebook and you can see how you can turn on the automatic quantization, so that when you ingest data that are float 32, automatically they will be converted, or you would have the representation of either scalar or binary within your collection or within your MongoDB database that can then allow for efficient retrieval of your vector, of the vectors are very relevant to your query. So we're going to put out some guidance on this, and there is on the MongoDB doc, there is some guidance around using this specific feature. So on the chat, that will be placed in later, or maybe in a second. Okay, those are some good questions. So keep the questions coming, and I'll try my best to answer. I think we're at the halfway mark. So let's go back to the agent. Then I will go back to the questions later, but keep the questions coming. So here we have the tool. So that's what we're moving on to. We already have an agent. We'll see what an agent in PydanticAI looks like. Now we're going to create an agent that has access to tools. And for those who just joined, the objective is to create an agent that can access information from the internet and access information from a knowledge base. Hence why we created the entire RAG pipeline and ingested some data into MongoDB to act as our knowledge base. So now there are several ways you can actually define tools in Pydantic. And for those of you that have used tools like LangGraph or CrewAI, I know in LangGraph there are also several ways of actually creating tools. You can use the decorator in LangGraph, and you can also use the decorator in Pydantic. So the patterns are kind of the same when you move from these frameworks, from one framework to another. So with Pydantic, you have the @agent.tool, and then you have the @agent.toolplane. So the difference is this as context. This is context aware. So wherever tool, which will be a function that this binds to, it will be aware of the context within the agentic execution. So you can pass in some specific data into the specific function. But toolplane means you don't need anything from the environment, from your execution environment. You just need whatever is within a function to execute to produce a result. So that's the difference. And there is also a tool constructor that you can use, and you can pass in a tool directly into the agent when you create the agent. So we're going to see all the different ways to create tools, and you might not have to use all of them, but I've just basically shown you all the ways you can create tools with Pydantic. So the first thing is we're going to be specifying some dependencies. So right now, what we can do is with Pydantic, and this is something that is different to other agentic framework, which is the ability to pass in within the tool or within the execution of your agent a specific dependency that is only accessed within the execution context of the agent. So here we're just going to be passing in the Mongo client, the database, and the knowledge base. You can also not do this and just have the global scope variable passed into the function. But this is good practice for production code, for production level or production grade, which is what PydanticAI is focused on, making it less painful to build production grade application with generative AI. So with their way of implementing, it's less error prone in some way. So if we're going to be moving on, so the first tool we're going to implement is to retrieve information from the knowledge base we just created. We're just going to retrieve the information. I've already done that with the custom vector search. Now we just need to wrap that in a tool. So to do that, when you have a tool that requires context, what we're going to do is specify the context itself and use the run context module from PydanticAI. And then the second argument that is passed in is the user query. So right now, I'm going to use that custom vector search function we defined earlier. And we're going to pass in the user query that comes in. And from the context and looking at the dependency, we can retrieve the collection we require. So that's it. And now we can actually extract the result, convert it to string. And this is a tool that our agent can now have access to. Well, not yet. The first way you can create tools is use a tool constructor, pass in the function, and then specify if it takes in a context or doesn't. We want this one too, so we're going to specify this as true. And this is similar to some of the other agentic frameworks out there. So the patterns are relatively the same. So we create this toolbox. I've called it toolbox because it's a list and we can put in as many tools as we want, or we can extend the toolbox a list to add in more tools. But right now we have a toolbox. What we're going to do now is, for those who started, you've seen this already, us creating an agent. We use the agent, a constructor, we pass in the model, we're using GPT-4o. We're then going to use a different system prompt here, which is we're going to just specify you get the latest news based on user query. You can make this as robust as possible. Then we're going to pass in the dependencies that we want the agent to use. And that's going to be the dependency we defined earlier on here. And then we're going to pass in the toolbox, which has the tool we want our agent to utilize. So here you can see this is how we're passing tools. This is the one way we're passing tools to the agent. And then we specify the number of retries we want the agent to take whenever it encounters error. So we specified it to 3. Now we can actually run the agent using the familiar run_sync. And we're going to ask it the same query, get me some news on electric cars if possible. And then we pass in the dependency we're using. And here we go. We can get the result. So we have it's just giving us some results. And these are coming from our knowledge base. So they're coming from right over, if I just go back to MongoDB Atlas, we're using vector search within our knowledge base, and we're conducting vector search from the user query, the numerical representation of the user query against the embedding of each of the documents within our collection to actually retrieve the 5 documents that are semantically similar, and then we pass that as the result. And this is all done inside of this custom vector search function defined earlier. Everything's available in the notebook on the Gen AI showcase. So here we have an agent that has access to a tool, and we're done. And it's simple again. It's as simple as that. We just have an agent right now. We define the tool, and we've just executed it. So now the rest of the notebook now shows you different ways to initialize tools. And the next step we're going to do is actually connect our LLM to the internet. Because yes, we have some knowledge base of articles, but time moves on. New information comes out. Now we want our agent to have a tool that can search the internet. And the way we're going to do this is by using a tool called Tavily. I've kept in the link here for you to be able to get your Tavily API key. But with Tavily, we can implement something we call a working memory. So this means that we have some collection or some memory component within our database or within our agent that is updated frequently based on information that is provided, and information within the collection is utilized for any execution based on a user query. So that's the aim here. That's the working memory. Humans have it, you have it, I have it. We're going to see how it works. The first we're going to do is the same thing. We want to be able to retrieve information from our working memory using a vector search. So we're going to create a vector search index definition like we did earlier. We have the function defined. We've already created a collection here. So we're going to specify that we want to create a vector definition and give it the vector index name vector index. And give it some time, your index will get created. And we do a cleanup just to make sure there's nothing in there. And there wasn't at the time of executing this. As you can see, 0 documents are in the collection. Again, we're going to be using a Pydantic base model. We're going to be creating a Pydantic model to ensure that any information we get from the internet conforms to a certain structure. And I'm going to go through some Tavily specific information, but there's documentation on the Tavily website to explain this. I'm going to be creating a ranking function, but without any ranking. But I'm creating this ranking function because Tavily requires for me to not use the default Cohere functionalities. I need to create a custom ranking function. And what this is meant to do, which is not doing, is meant to take in your document and take in your query and then use a re-ranker to re-rank the retrieved documents based on some new semantic relevance score. So it does the re-ranking. But we're not doing that. What I'm doing is I'm just getting the documents into the ranking function and returning back the same order of the documents, just to it will make more sense later down here. But the next second thing I'm going to do, the custom thing, is I'll create a function called save documents. Now, what save document does is when we get information from the internet, I want any information that has a high relevance score greater than, but that says less than. Yeah, that says less than 0.5. But if the document score is less than 0.5, we come out of the function. But anything else, we can actually save into the MongoDB database. But what are we saving? So one we're saving is we're going to get an embedding of the document, the content of it. Then we're going to then make sure everything conforms to that working memory data model that we created earlier. So the content, the site title, and the site URL and the embedding are all the information we need. So there's also the attribute added at, but this will be populated by default. And then we handle any errors. But one thing that this function does is it just returns the processed document. So one thing we've done is just return the processed document, and that's it. So any document we get from the internet conforms to that specific model, and also we generate an embedding of the content. Now with Tavily, one thing we can do with Tavily and the MongoDB integration is actually when we get information from the internet, we can retrieve it and then store it in MongoDB. So whenever we want to maybe conduct the same query, we don't have to go back to the internet. We could just go to MongoDB. And that's what this Tavily hybrid client does. You need to have your API key, specify MongoDB as a provider, specify the collection you want to save any information from the internet into, and then the index that you want to use, which is vector index. Now you're going to specify the embedding function that you have. I'm using the custom embedded function. It's called get embedding. And then you specify the embedding field and other attributes and the ranking function we created earlier, the fake ranking function we created earlier. But one thing we can now do is we could just test it out. Let's get some results from the internet. We're going to pass in the same query and get me some news on electric cars if possible. P.S. I don't own any electric cars. In fact, I don't even drive. So this is just coming from nowhere. Get me some electric cars if possible. And we use the hybrid RAG client that we defined up here, and we conduct the search operation. Oops, I am the kid. Okay, we conduct the search operation. And what we have is results from the internet. So we can see we've got photo galleries of, I guess, what looks like a type of car. I'm not a car person, but apparently this is best car to buy competition. But we have electric cars news and latest pictures from newsweek.com. And all of this information are real-time information from the internet. With Tavily, you can refine this and select what browser you want or what search engine you want to use and other information. But this is all coming from the internet. And one thing I can do is then specify again with the same client, the hybrid RAG client, the query, and then pass in the amount that I want to, when I make the query, pass in the amount of documents I want to retrieve from my local database, or also specify the amount I want to get from the internet. Then specify the function I want to use to save any foreign information that is not in my local database. So in one line, we're doing a lot of things, but it's when you're trying to build real-time systems, this makes it very easy to both build a system that connects to the internet and be able to save the information into the database without writing a lot of code. and then we run this, and then we get the results right here. So the first time this was run, it's going to get all these results from the internet. As we can see here, all these results are from the internet because it's only giving us 5 results because there's nothing in our database. But now what we can do is now turn this into a tool that our agent can use. And the way this is going to work is we have the agent over here. We'll call our agent, and we can use a decorator to say agent.toolplane. This is using, remember, if you remember this, the decorator toolplane just creates a plain tool, essentially, for lack of better words, that doesn't require context. So the other tool we created required context. This one doesn't. This one doesn't care about what's going on. We just want information in and we get information out. And that's what's happening here. And with Tavily, you can actually they have this beta function, which allows you to extract information from URLs. So I've just commented out because we don't need it. But remember, in our data set, each of these data points have URLs. So you can actually pass in the URLs to then extract the information from the URL within each of the data point you have in your knowledge base, and then maybe you can simulate some form of double clicking, like the agent double clicking on a URL to get more information. But long story short, what we can now do is run the same query, get me some news on electric cars if possible, pass in our dependency, and now we actually get 2 of our results are from our database, because you can see that the date is in 2023, but the rest of it over here are from the internet. So we have like some form of hybrid RAG, some form of balance. It's not really balance, but some form of balance between search results. But here we can see we have our agent that can connect to different tools and uses an LLM, GPT-4, to connect to the internet, to connect to the database, and performs different type of RAG. So RAG is in vector search, or maybe getting retrieval of information by the internet. And we're conducted embeddings and generated embeddings in different ways. There's a lot going here, but it's so simple with PydanticAI. I know with LangGraph, you have to define graphs, which some people like because it allows you to think of the workflow. Pydantic have their own conceptualization of a control flow as well. You can look at the documentation. It's still in beta, so things might change, but right now, it's very simple to use, as I've just shown. So another thing you could do with Pydantic, you could do a lot with PydanticAI, but another thing you could do is actually see all the previous messages that were executed. So we can see what we started with and when we first did our execution. So it basically, when we ran this current agentic flow, execution flow, we specified get the latest news based on user query. Then the agent knew what tool to use, because you can see that this tool call part is using retrieve information from knowledge base. So it retrieved the information from the knowledge base, which is fine. Then later we saw the information that was extracted. And then we have another tool call, if I just see it over here, to return part, get search results from internet. So it's just using 2 tools at the moment, and it's worked really well. And that brings us to the end of the notebook. Like I said, this is just the bare bones of what you can do with PydanticAI, but you can use this to start creating some useful applications, enterprise intelligence, financial analysis, research monitoring. So there are different use cases you can apply this foundation notebook to, and it's all available on the Gen AI showcase. And the link has been shared, and I think shared several times. So I'm going to go in and see if we have any questions. So if you have any questions, feel free to keep asking. In the meantime, for those of you watching live or not live, you can go into the Gen AI Showcase repository and you can fork this repository to get some access to some of the notebooks, some of the even data sets we have, or some of the example apps. We have apps in here as well, written in Java as well, covering semantic search and Spring AI as well with Java. So this is very robust, but it's very useful for you to learn this fast-moving world of AI, because apparently 2025 is the year of agents, and we're going to be here regardless of what form factor becomes dominant in the AI space. So going to the questions, do we have the ability to leverage the GPU in my machine for this code? Does PydanticAI allows for such level of control? So you can use GPU in your code. So PydanticAI allows you to access models from different model providers. So if you're accessing a model from Hugging Face and you have GPU access, you can actually use the GPU. You can actually use your accelerated compute for the execution of the model or generating tokens. So I guess if you're using Colab, you can just switch the compute over here to change runtime, and you can switch it to a GPU. And then you can use a provider like Hugging Face or whatever to get better models. So let's see, next question. Do you handle data validation and pre-processing with Pydantic in the application? So I guess probably came in a bit late to the session, whatever you call it. But we do use Pydantic. So we're not just using PydanticAI, we're using Pydantic, the library itself. We're using it to specify a data model, but we are not actually conducting any validation. Well, we are conducting some typing. So if you're not entering any string, you will get an error here. But you can also put some more validations around here, but we're just doing the bare minimum. And I can use Pydantic independently without any third party like OpenAI. Yes, you can. And if you mean, can I use PydanticAI without any third party like OpenAI? Yes, you can as well. You could use any models you want. You can switch out. So PydanticAI has, just to quickly bring up, they have a robust documentation, and I can see it's collapsed. So it's going to be hard to get. And just to quickly show, so they have the following: OpenAI, Anthropic, Olama, Grok, Gemini. But they also have the ability for you to create your own models as well, as in your own class to access different models. So you just don't have to conform to these models. Maybe you can cover how to use Logfire with PydanticAI. Yes, when we go into, maybe in a future video, we can go into the observability and the monitoring aspect of this agentic system. So Pydantic has Logfire, or they're promoting, or they're the creators of Logfire. LangGraph has Langsmith. And yeah, everyone's bringing out their own observability platform or monitoring platform, which is fine. It's all good. We're going to show it all here on the MongoDB AI show. So there are no questions. We go through all the questions. That's amazing. And I want to thank you guys for joining me at this very, very interesting year we're entering. So feel free to contact me on LinkedIn if you have any questions, or you can just get some code from the Gen AI Showcase. Feel free to contribute to the Gen AI Showcase as well. We get loads of pull requests, so feel free to contribute as well. On that note, that brings us to the end of this AI show. Thank you guys for tuning in with me today.